Thank you for joining this lesson. We're going to discuss number 1 of this paper, part A. The figure below shows a velocity time graph for a car. So we have the velocity in meters per second and we have time on the x-axis in seconds. The first part, we are told to find the total distance traveled by the car. Whenever you're given a velocity time graph, we usually say that distance traveled is usually given by area of the graph. So we're going to calculate the area of this graph, and we can see it is tracing the shape of a trapezium, whereby we're going to have two parallel sides which are having dimensions of, this is at 24 because it is from 0 to 24. Then this upper parallel line, which is from 4 to 20, will have a distance of 16. So we have 16 units and 24 units on the other line. Then the vertical units, which will give our height, are going to be 80 because it is from 0 to 80 according to the velocity here. Therefore, we shall use half the sum of the two parallel sides, which is 16 plus 24, then times the vertical distance between the two parallel sides, which is 80. Therefore, we're going to have 16 and 24 giving us 40. Then now we multiply 40 and 80, then we divide by 2. And we're going to get 1600 meters as the total distance traveled by this car. Calculate the deceleration of the car. So we are supposed to be in a position to observe the motion of the car according to the graph, and we know when the car was accelerating, when it was moving with a uniform velocity, and when it was decelerating. For instance, here in the first 4 seconds, we have the car accelerating from 0 to 80. Then now for 16 minutes, the car moves at a constant speed of 80, then starts decelerating in the last 6 minutes. The last 4 minutes, that is, from 20 to 24th minute. The last 4 minutes, we have a deceleration from 80 meters per second to 0. Therefore, now it is this portion where we have a deceleration. So we can say that the initial speed is 80. It is decelerating until a final speed of 0 in time, which is equal to 4 seconds. Therefore, acceleration is usually given by final velocity minus initial velocity out of time. And we have all the components here. So our acceleration is going to be 0 minus 80 out of 4. This is going to give us negative 20. Now, this is a negative acceleration, which is, in other words, called the deceleration. So we're going to have a deceleration of 20 meters per second squared. Part B. A car left Nairobi towards Eldoret at 7:12 a.m. at an average speed of 90 kilometers per hour. At 8:22 a.m., a bus left Eldoret for Nairobi at an average speed of 72 kilometers per hour. The distance between the two towns is 348 kilometers. Calculate part 1, the time when the two vehicles met. So what we should calculate first here is, a car is starting from Nairobi to Eldoret. This is at 7:12. Then later in the day at 8:22, which means now before the bus leaves Eldoret, the car which left Nairobi has already covered a distance towards Eldoret. So having the two towns as Nairobi, then Eldoret, we're going to get the distance traveled by the car, which began first at 7:12, before the bus started from Eldoret. So between 8:22 and 7:12 a.m., we're going to have 1 hour 10 minutes. So 1 hour and 10 over 60. And 10 over 60, whereby we're going to say this is 1 hour and a sixth. And we can change it to 7 over 6 hours. So in 7 out of 6 hours, at a speed of 90, we can see the distance it had been covered by this car. So 7 out of 6 by 90, we're getting 105. So the car had covered from Nairobi 105 kilometers. Now that it had covered 105 and we had a total of 348 kilometers, then now we can say that the remaining distance is 243 kilometers to Eldoret. This is the time when the bus now will start from Eldoret to Nairobi. So at an average of 72. Therefore, now the two vehicles are approaching one another. The relative distance, it is the distance between them, is going to be 243. And the relative speed, because they are approaching one another, we shall add 90 and 72 to get 162 kilometers per hour. Therefore, we have relative speed, we have relative distance, we can get relative time. This is the time taken by two vehicles to cover the relative distance between the same, using the relative speed of the two vehicles. So we're going to have relative time by taking relative distance divided by relative speed. And this is going to be, when we take 243 out of 162, we're going to get 1.5 hours. So 1.5 hours is the time they will take to meet. What time, or find the time when the two vehicles met. Remember, they started moving together at 8:22, and they are now taking 1 hour and 30 minutes. That is what it means by 1.5 hours. Therefore, they are going to meet at from 8:22, 1 hour 30 minutes. They are going to meet at 9:52 a.m. the same day. So this is the time they shall meet. And finally, we are told to calculate the distance from Nairobi to the meeting place. Therefore, they are meeting. Remember, from Nairobi, they had already covered 105 kilometers. So now they are going to travel for 1.5 hours to meet. Within 1.5 hours, we can multiply with the speed of the vehicle which is coming from Nairobi. This is 90. So 1.5 by 90 gives us 135 kilometers. So it means the car will travel for another 135 kilometers. And it had already covered 105 from Nairobi. So the total distance from Nairobi to the meeting point will be 135 plus 105. This is landing us to 240 kilometers. Alternatively, we could have considered the vehicle which is from Eldoret, whereby we would have said this vehicle will travel for 1.5 hours to meet the vehicle which is from Nairobi, and it is coming at 72 kilometers per hour. So 72 by 1.5 hours, we're going to get 108 kilometers, but this is from Eldoret. This is the one from Eldoret. So this from Eldoret, we can get the distance now to this meeting point, but from Nairobi, which is going to be the total distance of 348 minus 108, and we shall land at 240 kilometers from Nairobi. So this is the same distance calculated differently. Thank you for following. Subscribe and share.